Well, everybody, we're so excited to have with us Megan O'Connor. She is the CEO and co-founder of Nth Cycle, and I just found out they're located really close to us, so maybe we can go visit them sometime.
Nice.
Thanks so much, Megan, for being with us.
Yes, thank you guys for having me on today.
So this is a really big topic with our viewers, with us, batteries. Those of us in the know, we know that this is a big thing. Most people in the world, of course, outside of this bubble, don't know what we're talking about, but we know that batteries are here to stay with EVs and that there's going to be more and more of them. What do you guys have to do with EVs and batteries?
Yeah, so Nth Cycle has developed a new technology to be able to affordably and environmentally recycle all of the different metals in these EV batteries in your cell phones and your laptops, right? We use them in almost everything in terms of electrification today. And so that we recycle them to put these metals right back into the supply chain so that we can rely less on essentially mining them from the ground.
So we visited Ascend Elements. We talk all the time about redwood materials and life cycle. What is the same and what is different about the way that you're doing it?
Great question. So Nth Cycle is really the new technology provider. And so we're not trying to vertically integrate to try and go all the way from collecting these batteries to shredding them to chemically processing and then making new batteries, which is what a redwood materials is doing. We're trying to innovate and really make a new, better way to just chemically process these materials. So we work with folks like Redwoods and Life Cycles and Ascend Elements who are being that logistics partner and taking care of collecting all of them and shredding it down into what's called black mass, which is really the cathode and the anodes. Think lots of graphite or carbon, and then the metals that we want to pull back out like cobalt and nickel. And then what Nth Cycle has done is created a completely new way to chemically refine these materials back into metals that can go back into the supply chain. So instead of using harsh acids and solvents or smelting, which uses large, think of it like a large furnace, so very high temperatures and pressures, the only thing our technology uses is electricity and water to be able to pull these materials back out. And so it's a much more sustainable way to do this, and it's modular. So instead of having to transport all of these batteries into one centralized facility, right, as we know, right, a lot of us still have a lot of cell phones and things in our sock drawer, or EVs end up in all these various places. And so what we've developed our technology to do is to be able to go wherever this waste is instead of having to transport the waste to us. So it's a very modular, regional play on our side from a business model perspective, but then also from a technology perspective, so that we can really reduce the cost and transport and really increase the amount of safety that goes around bringing these materials, into the proper end of life management.
All right. Now, I don't know if you're going to be able to answer this question, but how does your technology work?
What's the secret sauce?
How do you get the very expensive metals out of the black mass of the battery?
So my favorite analogy to use, which I'm sure people are probably sick of hearing me say, but it's like a Brita water filter. It's right. The Brita water filter that you have at home for your drinking water. In that Brita filter, right, you're filtering water. If there's any heavy metals in that drinking water, it pulls it out in that cartridge that you stick in, which is all activated carbon, right? So it's very non-selective, and that just pulls everything out in that one stage. We've taken that same basic idea of filtering a water solution with metals in it, with carbon, but figured out a way to electrify that carbon filter, because different metals have different affinities for different amounts of electricity. And so if we apply a specific voltage across one filter in our system, it will collect, say, copper, and then we have multiple of these filters stacked in series, each with a different electrical current applied, so that we can pull all these different metals out in that final powder form that, again, can go right back into the supply chain.
So if I heard you correctly a few minutes ago, you are working with some of these other companies that we mentioned, like Life Cycle and Redwood Materials. Does that mean that you're helping them develop their technologies? Can you kind of can you kind of explain more about that?
So we're working with companies who are all in the logistics side. So not necessarily with the players that I mentioned, but folks very similarly in the sort of collection, logistics, and shredding operations. And so these companies have been around for decades, recycling other types of batteries like lead acid, right? We have a very high recycling rate for lead acid batteries, and they're seeing the same types of materials like lithium ion come through those same channels. And so they're trying to figure out, how do we now recycle this brand new stream of batteries when we have this, very robust recycling process for lead acid. But these players don't necessarily have the $500 million to $1 billion that it costs to build out a centralized hydrometallurgical facility, right, where they use all these acids and solvents that I mentioned before. And so they essentially have to sell it as a waste product and ship it right now overseas to China to be processed into anything usable. And so what we can do is partner with those folks and help them, because again, we cover the CapEx, we cover the cost of the system, and simply charge them a fee to process and upgrade the material. So we don't own the waste product coming in and we don't own the product coming out. We're simply there to help them be their upgrading partner. And so they love that, where they only have to pay a small fee and get a product that's 3x the price that they would have gotten for the waste itself.
And so that implies that you guys are able to build these systems cheaper than the competition?
So in turn, we're at cost parity with the way it's done today, but we're able to provide a much higher grade product that can be dropped right back into the supply chain versus a specific product for battery manufacturing that has to be validated on the other end.
So I guess, like, if I put my investor hat on, I'm always curious, like, how, obviously you have IP that, you know, makes it so you can do this and protects you, but like, what if Jesse and I visited your factory and we're like, aha, all we need is a 12-volt battery and we can, you know, we can copy them. What protects you from other companies seeing how this is done and then just trying to do it themselves?
That's a great question. So the way that we have developed the system is with all off-the-shelf components. So nothing in our system is something that we make in-house, but all of our IP is in how we assemble and operate those systems. So there's a lot of trade secret to what we do, and we also have IP on how we actually assemble the system itself. And so Nth Cycle does all of the assembly in-house. So you'd have to really work hard to crack those open on site to be able to figure out, you know, how we even assemble them, but then, you know, no one will ever know how we actually operate. And so that's really where the secret sauce is in the combination of those two things.
So a lot of people we talk to who are for some reason against EVs, they're always saying that, well, the big problem is batteries. You got to mine all this material. We will never have enough batteries and so forth. And what is your response to that in terms of recycling? Do you think we'll get to the point where we will be able to almost make this a closed loop, where we could take a Tesla battery, let's say that's worn out, and be able to recycle it and put it back into another car?
Absolutely. And that's what Nth Cycle's mission is to create that closed loop society where, you know, all of the materials that we need are already in circulation. So they're in another battery that we simply just have to recycle it and put back into a new battery. And for every other type of material, right, we hope to do that with catalytic converters and the magnets for our motors and EVs and things like that, right? Because these are all critical minerals. And I think batteries, right, are at the top of people's minds because there's been so much disruption, especially when we look at nickel, right, with the Russia-Ukraine war, and now the Inflation Reduction Act has put really strict, compliant regulations on OEMs of where they can source their materials from. And so this is a problem across the various metal supply chains, right? Because these critical minerals are essentially the building blocks of the clean energy economy. And not a lot of people realize that. And so I'll say, like, I do think that there is a much better way to mine and refine these materials. Unfortunately, we won't get to the point where we have enough material from recycling alone to get us to that compliant supply number. I don't see that happening for many decades. And so what Nth Cycle does actually, in the way that we developed our technology, is to work across the supply chain, both on recycling of all types of scrap, not just battery, but also in the mining space as well. Because if we have to continue to mine, which we will, to get to the numbers that we need, but why not do it more sustainably, right? And so this market we're seeing in this side of the supply chain, the upfront side of the supply chain, is now open to innovation for the first time, in at least my lifetime. And so we're very excited to see that there's momentum in the space to start using new technology to create, a much more robust and sustainable supply, so that we don't have, these critics saying that there's this dirty side to clean energy.
So, okay, well. Oh, wow. Hang on. So, battery recycling is fun and exciting. And I think that a lot of people are getting really excited about it because they know that there's this big tidal wave of cars that, we produced 10, 15 years ago that have fairly large lithium-ion batteries that are going to be on their way out, so to speak, and we're going to need to recycle them. But you just talked about mining. Talk to me, how do you use your technology in terms of mining? Because when I think of batteries, they're already good. All the stuff in them has already been nicely refined, and it's all good stuff. It's just all jumbled, and we just got to pull it all apart and then put it all back together again, basically, to make a new battery. But when it works for mining, there's a whole bunch of dirt and rocks.
Crushing involved.
And crushing. And so how does your system work in on the mining side?
Yeah, so it's funny you say that. I see it almost very similarly, where it's mining in both senses, but one's urban mining and then one's the traditional mining that we think of. Because in both cases, we have to collect the material from very remote areas. We typically have to transport it. We have to shred it, right? So there's that mechanical processing stage, and then we have to chemically process it. And so we're the chemical processing stage in both and sort of both applications. We sit at a mine, or we can sit at a mine. And we let the partner, dig it out of the ground and do that upfront sort of froth flotation, like early stage concentration step before we come in and take that concentrate and turn it into the much higher grade product. But the novelty of what we can do is, again, we have the ability to do it on site, so you don't have to transport all that really low grade material, which is a huge problem here in the US because we don't have the high grade ores that you'd see overseas. Be able to process it into that biomaterial and keep it here with the United States, right? If you look at, the life of a nickel, one single compound, it travels, 7 times across the world before it ends up in an EV here in the US. And so recycling can help keep it here, but then what if we could also mine nickel here in the US and keep it, the whole supply chain here, right? So there's multiple pieces to that we're trying to solve. And one of the biggest is, again, just the transportation alone that's needed on both sides. So it's both, the logistical piece of how can we get as close to the source as possible while being flexible enough to be able to process that all with essentially the same unit economics, which is what we have achieved here at Nth Cycle.
So what kind of processes are you replacing? So if I had just a regular old nickel mine and we do it the old-fashioned way, what kind of processes are they doing that you are going to be able to replace? And then what's the impact of that?
So if you think about, like you said, just a kilogram of nickel being mined, say, up in the Arctic, it first has to go to a smelter. So that smelter will take that very low grade concentrate and turn it into what's called a nickel matte material. That nickel matte will then have to go all the way over to Europe to be processed into a high grade material that will then go to a, say, cathode manufacturer for thinking about an EV battery pack. And so what we're able to do is help skip over 2 of those steps. So you can skip the smelting step, which is the most carbon intensive part of the mining process, actually is in the chemical refining stage. And so that's where we're really making the biggest impact in terms of carbon emissions and carbon footprint of these materials, is in enabling folks to skip over the smelter and then to skip all the transportation in between, right? We can essentially eliminate 2 of those transportation steps and the smelting, which is how we're able to reduce the emissions by 92%, which is pretty astounding. So we just had that third party validated, which we're very excited about.
Wow. Okay, so I mine up some ore, which is basically dirt that has a little bit of nickel in it. Normally, I would have put it in a smelter, and I'm assuming coal-powered smelting. Okay, great.
Yep.
Not great.
not so great.
Not great.
and then ship it halfway around the world to have it be refined even further, some more, and then you ship it to the cathode. Okay, and so now I mine it out of the ground. I do this sort of early frothing step, and instead of putting it in the smelter, I'm going to basically feed it through a big Brita filter, which is your system. And what do I get out of that? Do I get like powder? Do I get big sheets of nice nickel? What does it look like? And then what do I have to do to it to make it into a battery?
So we pull out metal powder. So it's a big pile of powder that we can pull out. And depending on the end use, so if it's going to a battery, it'll have to go to one final finishing step, but we can still skip over, again, most of that final finishing step because of how high grade the material is. Or if it's for any other type of nickel end material, it can actually go right into the manufacturing process of those other end uses. So it's, again, enabling us to skip over a lot of the really painful points of the supply chain today.
Wow.
This so my too good to be true detector just went off, and I want you to help me here because it just sounds awesome, and I know that all throughout the comments right now are going to be people going, sounds too good to be true. Why haven't I heard of this? Why isn't everyone doing it? So how did you guys? I guess I want to go back a little bit. How did you guys figure this out? There's a lot of smart people out there who've been doing this kind of stuff for years. How did you guys figure out how to do it better?
So it started back in 2009. It was my co-founder, Chad Vasitas, who was a full-time professor at Harvard, and he has a very unique background for his PhD work. He was all in membranes. And so lots of like wastewater treatment and things. And then for his postdoc, he was in another membrane lab, but did more on like the electrochemistry side. And so it was his idea to put together like this carbon membrane with the electrochemical piece, because he thought by combining those, you could overcome the inefficiencies that both had on their own, right? In traditional water treatment, we have a lot of fouling, right? Material gets stuck to the membrane and then you can't use it anymore. And then with electrochemistry, right? This is done at scale. This is in copper refining. This is not a new technique by any means, but it's what's called a batch process. So it's a big, they think vat of acid with metal in it. And there's two big metal sheets in there that have an electrical current applied, and it just sits there. And it's very slow for all of those, say, copper ions, if it's a copper refinery, to actually get to that metal plate over time to be recovered on that surface. And so it's very large, it's a lot of CapEx, and it only can work for one metal. And so Chad thought, okay, if I put it with a membrane, I can actually push fluid through that essentially electrode and be able to overcome that really slow, inefficient process that works really well, but it's just really slow. And so he developed it for a completely different application in wastewater treatment. Think removing the really hazardous, dirty dyes that you use in like denim when you make denim, right, to turn it blue. And so his lab did that for many, many years at Harvard. And I didn't meet him until 2014, when I saw him just give a talk at an academic conference on this. And I thought, wow, this is a really cool dude. And he developed a really awesome technology. And I sort of left it at that. And then a couple months later, I had the unique opportunity to listen in to what was called a Green Electronics Summit. It was a really weird name for a famous professor at Yale who had invited folks from like Apple and Dell and all these, consumer electronics companies to Yale to sit down and talk about the sustainability issues they saw from a corporate level, 5 to 10 years down the line, to help direct, the Center for Green Chemistry and Green Engineering's research. And so, of course, it was completely closed to students, but I had to be a fly on that wall because I was reading more and more about all things critical minerals. And it blew my mind that not more people knew, again, I hate to use this phrase, but the dirty side of clean energy, and that nobody was focused on innovation in this space. And so I basically banged down this professor's door for 3 weeks until he finally, I think, gave in because he was sick of me and didn't want to deal with me anymore. And he was like, fine, you can come into this meeting if you take notes. You're basically the scribe. He's like, you can't talk. You can't give any feedback. I'm like, that's fine. I'll just sit there and take notes by hand. And so that's what I did. And the two things that we heard over and over again was, that companies knew they had to recycle, right? I'm talking about like Apple and Dell, like they try to lead the way in terms of transparency and, their environmental or ESG goals. But there was really no way to do that, especially here in the States and in Europe, right? Every type of recycling happened over in China. And then the second problem that they faced was the supply chain. They knew there was simply not enough cobalt and nickel in circulation to be able to meet our electrification goals over the next 10 to 20 years. And as consumer electronics go, there's like small potatoes, right? And how much cobalt they use compared to an EV. And so I walked into that meeting wondering like if there was a way to innovate in the recycling space. And it sounded like it was the chemical refining process that was the real limiting factor. And so I thought about what I had seen in the past year, and then like Chad's technology popped into my brain, and I was like, wow, like I wonder if this could work for this application. So I went to him and I was like, hey, look, like I hate my current PhD project. Can I go work on this instead? And he's like, sure, I don't care. I've always wanted to do this, but never had a student interested. In the meantime, my advisor was like, you're crazy. You're in your third year. You're never going to graduate. My poor husband's like crying in the corner because I'm never going to leave school. But I decided I had to do it because I just felt like there was a huge opportunity because there had really been no innovation in this space. So anyway, we worked on that for the next 3 years. And then we had literally an oh shit moment of like, wow, this worked way better than we ever anticipated. Like the recoveries are high, the back of the envelope calculations for what the unit economics look great for the little math I can do. And then, it was really like, okay, how do we commercialize this? And so I decided to take the risk and take it out and knew that I could find the people to join my team who have done this before, right? Who have either scaled technology or have thought about creative business models and who have been in the mining industry for a long time that saw the pain points as we saw them and could even help us dig further into like, where could we actually help solve this problem? And so that's what I'm really proud to say that we did is not just the technology piece, but also the team that we've been able to assemble who, just a phenomenal group of people who have experience in all of the sort of areas I just mentioned. And I'm very excited to say that we're finally at commercial scale and hoping that, we can get our first project out next year.
Wow. I want to go back to this sort of technology being used to remove waste from like water. How long has that been sort of a technology, or was it just sort of coming online when you heard of it?
So it had been in development in Chad's lab for, I would say, 5 years before I came along. And so he was using it. If we think about like a traditional electrochemical cell, right, you have like the cathode side, and then you have the anode side. He was using it for the anode side with removal of those organic dyes. And then the metal side is sort of the flipping it in reverse and doing more on the cathode side. And so he hadn't done it really. He did a little bit of that work, which is what I saw the presentation on, but very little until I took it and sort of ran with it for the next 3 years.
Because this to me is the thing that I see again and again when it comes to disruption. It's always kind of this technology that was being developed for one purpose, and nobody really thought, oh, we could use it, and instead of what we're taking out being waste, it could be the thing that we actually want to have. And so disruption always seems to take a technology that has been developed, using it for a different purpose. And I always kind of think of it like a tech tree, how we're like, oh, why didn't we think to use, lasers for this application? And you're like, oh my goodness. And that's where the disruption comes in, because he had already spent 5 years working on it. If you had come in with this sort of idea and you're like, I think I want to do this for batteries, but there was no such technology, it would have been much, much slower. We would be talking to you instead of in 2022, we'd be talking to you in 2027, and that's when the technology would have been coming online. But that is so cool how you saw a problem and you saw a technology that could be the solution, and you decided to put those two things together, and that is how you get disruption. Wow.
That is so cool. I want to ask you, so basically we can take this black mass, we can put it into a container, a tub or something, and can you just list off what I can pull out? So, we heard nickel, but like what else can we pull out?
So we can pull out the nickel, the cobalt, the manganese, the graphite, and the lithium are the real major components in there. So there's a lot of good stuff in that black mass.
Wow. That's almost all that we hear about with the batteries.
And so basically, let's say I take the black mass. Am I just kind of dumping it into some water, and then we're going to feed it through the system, and then we're going to take these powders out, and I'm going to have some water that still has some stuff in it, but no longer any of these powders? And what does that look like on that end? What do we do with that stuff?
Yeah, so the pre-processing that we do is a low volume of acid. So we do use some chemicals at the front end just to dissolve the metal into that water-based solution before it goes into our electroextraction unit. And so once that goes into our system, we pull out all the metals, and on the back end, it's actually regenerated acid. So our system sort of consumes the acid on the front end and then regenerates on the back end. So it's actually a closed loop. We can loop that acid right back to the beginning. So we only need like a little bit of upfront chemical material, and then our system sort of does the rest for us, which is really nice. So we eventually will have to put that to waste, but it's something that we can simply neutralize and put down to traditional wastewater treatment because there's no hazardous materials left in there.
That's so cool. All right, so you just mentioned that you finally got into commercialization. That must be a really exciting thing for your company.
It is. I think my staff is sick of me saying like, this is an exciting year, because every year is an exciting year. But I have to say, like, this is a particularly exciting year because we are finally at like the full scale commercial system and have line of sight on our first facility in the field. So
now, from an investment point of view, from a company's point of view, what was it like to start this company? Because you were a student. And now you're a CEO and co-founder of a company. What was it like to go from being a student to running a business?
Oh, crazy past 5 years. I would say students, I make this joke a lot, PhD students make the best founders because we're used to being poor and we're used to making mistakes and learning every single day, right? And so I, threw around the idea and asked a lot of people for their advice on whether I should go get an MBA or not, or even take an executive MBA program, right, just on the weekends. And they all said, no, like, we think you can learn it along the way if you're willing to put in the work, right? And so I essentially felt the same to me in terms of like the amount of learning you do every single day, every single year, and how you have to pivot into sort of what hat you wear on certain days. So I really enjoyed that transition of being more on the technical side to being more on the business and how do we actually make money off of this side, and how do we create these partnerships? Because I always thought I was like a good scientist, but I was great at the communication piece. And so it was nice to sort of find that balance of where I could sit in the company. And, it's really just been finding the right people, right? And admitting when you don't know something, right? I think great CEOs, at least the ones that I've looked at and tried to study, admit when they need somebody on their team who can do it better, right? You don't have to know it all. And so I've tried to find, those stellar people who can help me, think about things in a creative and different way that I might not have ever had experience with.
So if people are watching and they're getting as excited as we are about learning about your company and they want to possibly invest, is there anything coming up, a crowd fund or an IPO or something where they could get involved?
Absolutely. We're actually in the process of raising our Series B round, $50 million to help get us out into the market very quickly, especially with this massive opportunity that the Inflation Reduction Act has created. So please email me, O'Connor@nthcycle.com, or visit our website and drop us a note there.
Talk to me more about the Inflation Reduction Act, because that has just been, it was this bill that I think Jesse and I can admit now really thought wasn't going to happen. Like we had hoped for it, and then we thought,
put it to rest.
Yeah,
in my mind,
exactly.
and it wasn't called the Inflation Reduction Act at the time, but I had emotionally and we had just all gone, oh, okay,
it's not going to happen.
One guy from West Virginia is going to ruin everything for everyone. And then it turned out that it wasn't going to, it happened.
Right.
And it happened, honestly, better than I could have. Congress, you did that?
Right.
Really? Wow.
So tell us, what is the impact for your company with this one bill?
I have to say, I was in the same, I think all of us here at Nth Cycle were in the same camp. We're like, this is never going to happen. Like, put it aside, like, think about the future, think about Series B. And then it was signed and we were like, oh my God, like we have to like postpone our raise to like dig. I mean, it took us like 6 weeks to dig through. It's so much information. And God bless my CFO, who he actually read the whole thing. Like I have no patience for that.
So there's only 2 people on earth that have read it, right?
The person who wrote it and wow.
And my CFO.
Right.
But the impact, it's huge. I think, right, this is a historic moment for the US. Like we have finally done something right, as you said. But I don't think what people realized was how big of an impact this is going to have on our supply chains in the near term. Like if you look at, again, I'm going to use nickel as an example because it blows my mind. If you look at a pre-IRA world and right where we could pull nickel from, we're technically in a world of oversupply. There is more nickel in circulation than what we actually need, which is great. But then if you look at a post-IRA world of where it comes from and where we're now allowed to pull from, if you want to be able to give consumers those tax credits, 13%, only 13% of the world's nickel is considered compliant. Wow. And the majority of that comes from Canada and Australia, where the most expensive types of nickel are made. And so now, OEMs are scrambling, right? Folks like Ford, who have very publicly announced that they are going to pull lots of nickel from Indonesia, are now like, okay, where are we going to get it from if we want to be considered compliant? We just announced this like 3 months ago. And now we're going to have to pull from a more expensive source of nickel because Indonesia produces a cheaper source of nickel to make batteries from. And this is the same across really every OEM is struggling with this because we don't produce that much here domestically or even in the EU where they're facing very similar problems with their regulations, but it's more from the carbon footprint side. 40% of every EV battery that is made has to come from either domestic sourcing, so it could be recycling, it could be mining here, or from a country with a fair trade agreement, which again is Canada or Australia for us essentially. And so it's leaving us with this massive gap of about 150,000 metric tons of nickel just in 2024 and 2025 alone, Doesn't seem like that much, but that's a lot of EVs that won't be able to be made with critical materials. And as a consumer, right, the tax credit is $7,500. If I'm going out and I don't have an EV yet because I haven't been able to afford it, if I'm going out and buying my first EV, which I hope to in that time frame, I'm certainly going to go with the OEM that's going to give me $7,500 back, right? I think most of the folks who still have to buy an EV, it's going to be a big driver for them.
And that 40% you mentioned, by the way, goes up every year or every couple of years. So it gets worse and worse for the manufacturers.
Is it possible, or did we mess something up? Is it an impossible task to get enough of these critical minerals from the sources that we've outlined that we want to get them from?
In our eyes, it is not impossible, but it is improbable. So if you look at, again, like one source in particular, right? Because there's the companies and the technologies out there today are really hyper-focused on just mining or just recycling of batteries. And that's why Nth Cycle is trying to take the most holistic approach as we possibly can and be as flexible as we can with both our business model and the technology, because there's about 100,000 metric tons of nickel that goes unrecycled every year, but that's not in batteries. So it's in slag from stainless steel, like the catalyst from oil and gas industry. It's from all of these like sort of heavy industrial processes that really go unrecycled, right? That's waste to people. But if companies like Nth Cycle, which we do plan on being operational at that capacity in 2024, we can pull that 100,000 metric tons out of all these different waste forms that really nobody else is paying attention to at least get us close to that 150,000 ton deficit. And so not impossible, but
wait. So I started off this interview and I thought that I was talking to a battery recycling company. Then you tell me, well, you know what? We can also do the mining. Now you're telling me, there's all this crap that all these different industries have where there's unrecycled nickel, and we could be getting nickel from garbage.
We can. And we need to call ourselves a metal refining company, right? We're really we're the chemical refining piece that the world is missing because it's very inflexible. We have very inflexible refining right now, and that's something that we're trying to change. And so I think batteries is an easier place for us to start because there's so much hype and there's so much material in there, right? It's an easier to recycle material. But we're trying to get like all of the garbage, as you said, the world's garbage that has these really valuable materials in it to get as much back into circulation as we can.
Is your phone and email just ringing off the hook?
I say my BD team has I don't want to say easy job because they do a very good job and it's very hard, but we have all inbound interest, which is phenomenal. Because I think people are finally starting to realize that this is a problem that needs to be solved, which is really exciting because even a year ago, this is not a problem that we had. So it's a very good problem that we have now.
Well, I think we have to go visit for sure. I mean, we're only down the road.
Please do.
So
sure.
You're going to geek out.
Yes.
I know it.
But I have to know, I just have to know a little bit more about this industrial stuff. I know that people have been watching this interview already for 30 minutes, but I've got to know. So talk to me. Obviously this isn't going to be probably as like nickel rich as say a recycled battery, black mass, but how much you're saying a lot of nickel is going unrecycled. You said stainless steel slag. So obviously stainless steel has nickel in it. So there's the slag, there's catalyst from the oil and gas industry. Okay. And that has nickel in it too. So is it just the same system? Do you just take the stuff and do you have to crush it? Do you have to do anything special to it in order to feed it through your Brita system?
Yes. So we do work with the partners who collect that material, and generally they have to shred it, even if they were going to ship it overseas to landfill it, for example, or refine it in some capacity. So we simply take what they're already shredding and put it into the same system, which is really the novelty or the innovation is that we have a really wide funnel of what's considered acceptance grade for us, and turn it into, again, a product that can go back into essentially any OEM's supply chain.
This is why I love this job, by the way, Jesse. We do a lot of interviews, and I think a lot of people think like, oh, this sounds like a boring company I've never heard of.
Yep.
The reason why we're talking to disruptive companies is because they're doing exciting things. And I know that mining and recycling sounds boring, but it's not, especially when you know what's happening in the world. This is amazing.
Yeah. I have more questions. Okay.
I can see the gears.
How many other kind of metals can you pull out? Is it just nickel and cobalt and those kind of fun ones? Or can we do gold? Can we do aluminum, titanium?
we can do almost any metal on the periodic table. So we have focused on cobalt and nickel, but the mission of the company is to work on the list of critical minerals that the US and the EU have deemed critical from a supply chain and then simple use perspective over the next several decades. And so rare earth metals, right? So all of the metals in our wind turbines, the magnets in our wind turbines, they're what makes up the motors in most electric vehicles. They're the magnets that are in my headphones right now, most likely. So they're everywhere. We can do catalytic converter recycling. So the platinum and palladium and rhodium and all of those really high value materials in catalytic converters or internal combustion engine cars. And yeah, things like gold, silver, all the different precious metals. So I hate to call it a platform technology because I feel like that's an overused phrase, but it really is a platform technology.
I think I've got you though. She said, it's a closed loop in terms of the water and all that, which is great, but electricity, she needs electricity. I bet you use a lot of it, and that's probably the bad side, right? You got to use a lot of electricity to make this work. Gotcha.
We do use electricity, and even with the grids as they are today, we still, again, can reduce the carbon emissions by 44% compared to the best-in-class recycling technologies out there. And then the 92% I mentioned earlier for refining. And so if we can, have a clean grid, it's even better, right? And so hopefully we get to that. But that's really where the benefit of our technology comes from, is the ability to pull electricity from a clean grid in the future, whereas other technologies who use fossil energy to create chemicals, right, will never be able to have that benefit. So that's really how we see the technology having an even greater benefit in the future.
Thank you so much for talking to us today, Megan.
We're definitely going to have to visit.
We're definitely going to have
Please
to visit.
do.
Yes.
You're not that far. You're not that far. We'd love to give you the tour.
Absolutely. Wow.
Awesome. Wow. It's so great to meet you. I'm so excited to hear about your company. I'm so excited to learn about next year when you start commercialization and where you're going to be. And wow, this is really cool stuff. So everybody who's watching, comment down below if you have some questions so that next time we're visiting the company, we'll have some questions for their scientists. And thank you again, Megan, for making the time for us today.
Yes, thank you. This was great. Thanks so much for having me on today.